Okay, so we just learned a little bit about bio-macromolecules and where they're found within our bodies, the different types. So now we're going to do a little bit of a group activity to get you more familiar with what bio-macromolecules are made up of and their relative size to one another. So macromolecules are composed of chemical elements. And so I'm sure that you've all heard of a periodic table, right? And then we've talked about carbon before in class. So some of these macromolecules you're going to compose out of carbon, and they have other chemical elements along with carbon that help them become what they are. So everybody should have a packet on their table, and if you look at directions, we want small groups, which looks like everybody's in, and you're going to use your Play-Doh and toothpicks to build and assign macromolecule. So I'm going to assign carbohydrates to this group. You're going to build glucose. This group, you're going to build the nucleic acid, which is guanine, which is the last one in your package. That back corner, you're going to do glucose, and you guys are going to do guanine.
Should we do?
Okay. Guanine, nucleic acid, last page. And so whatever you were assigned, there should be a 3D like structure to kind of help you out when you're building these. And I gave you the chemical formula. So for example, if you have nucleic acid, you have C5H5N5O. Does everybody understand what the numbers mean? That's the amount of each chemical element that makes it up.
Yeah.
So then you and your group are going to work together to determine which color you want to use of your Play-Doh to represent each chemical element. And then using toothpicks, you're going to bind them together to look something similar to the 3D structure that you're given in your packet. And then you're going to want to use the periodic table at the back of this packet to identify what each chemical element's atomic mass is. So for example, like hydrogen is like 1.008, that's its atomic mass, and that's in grams per mole. And then you're going to calculate the molecular weight, and there's an example in the instructions on how to do this. And then finally, once you have your atomic weights and your molecules built, you're going to compare with the groups around you and get a whiteboard and a marker to make a scale. So your first scale is going to be of the chemical elements, and you're going to rank them. You can either do a flow chart or a pyramid. Say, okay, well, oxygen was the biggest and carbon was the smallest. Whatever you find in your results, you're going to build a scale. And then you're going to compare what you built to other groups, as well as the two really big ones in our packet here. We have cholesterol for a lipid and keratin for a protein. And you have to build a scale based on that. Do you have any questions on the instructions? Okay. Start. Yes.
This is glucose, right? This is on the back.
Yes.
Okay.
Go ahead and start building your molecule.
Black is carbon.
Hydrogen white.
Carbon.
Carbon's the biggest. The double bond.
It's close. Carbon.
But you guys understand, like,
They're the same.
I'll do it.
Are you doing a time?
They're the same.
It's like size increases.
Oh.
The sizes have to be relative?
Oh.
Yes.
Yeah.
Okay, so we have, so I thought.
And you guys have a periodic table there. Yeah, it's a look up any atomic masses.
Where is
What
it?
the,
All right.
These are the black.
remember that we want these factors to be relative. So like your
Can we make
hydrocarbons.
carbon?
What is that?
A little bit.
Okay, look up your atomic
This
mass.
might not be the scale.
Okay, oxygen is larger slightly. Here's the scale. Make it a little bigger. Yeah, perfect.
Whoa.
Alright, so we have
This is how this is.
No, bigger
Oh,
than
yeah, because the hydrogens are going to.
I'm black. Here's a final hydrogen.
looking really good, guys.
You like our little snowballs?
No.
You guys fly?
It'd be hard to choose.
Nitrogen?
Wow.
Is like
Great, how are you?
what is between?
I mean, it should be pretty close. One's like 2 bigger and the other's 2 bigger than that. Like you getting hydrogen.
2 hydrogen current and.
Wait, hold on.
Okay, as you guys start to get your molecules close to done, you can divide the work in your group and somebody can start looking up the atomic mass for each chemical element that makes up your macromolecules.
Oh, is that like this?
5, 8, 7, and 5.
There's more than one. Which one? Is that right?
Each one of these, okay, oh yeah, each one of these have that hydrogen.
Okay,
Because sleepers are five together, right? All of them, I have one.
The worst kind of
got it? Okay.
Alright,
So then you need to calculate molecular weight. Okay, awesome.
I have good
You guys want to
summary.
look up the atomic mass, then the molecular weight.
I mean, you do.
Yep, I will do
That's
that.
like 20 acres.
We've got more, we need more hydrogen. Not all the hydrogen.
Oh,
Oh, no, 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 I think they all have it, yeah.
Yeah.
You know,
16.
Can we have one person in your group look up atomic masses or molecular weight? Awesome, thanks guys.
72.
Yeah.
16. So.
cool colors.
6, 5, 8, 7, 5.
Okay, yeah. One, so one there and then on top. Okay.
What about this?
You need one more hydrogen.
Yeah, I think they do one more.
Oh, no, you have it.
Okay, what else was the five?
Okay, so we're gonna find the atomic weights of each part of the CFC situation.
Oh, like the last one.
Okay, and then you're gonna find the molecular weight, there's something in the front on how to do that.
That's it.
Yeah,
Nailed it.
Discuss this.
What's the max?
For the.
Done.
How are we doing on one?
I did, you want?
Done.
There. Is that right?
1, 2, 3, 4, 5, 6.
Find out soon.
No, because that's only 5
I'm so
persons.
sad I forgot to play that.
Oh my gosh.
I was
Isn't it like,
You tell us.
So one person from your group,
So soft.
compare your
Tiny little
relative
thing.
size to theirs.
That actually was fun.
And see what they look like, take turns. You guys that had
Well, it's just-
guanine, go look at their glucose molecules,
Ours
see
is the prettiest.
how big, how small, if it's approximately the same size as yours.
Quality.
You guys had guanine, right? So look at their
Get a little bit of rotation in Harvard card side.
Same with you guys, you guys had glucose, look at their guanine, see the relative size.
What's guanine?
Okay, so in our last few seconds here, guys, so I can have you listen while you're still working.
Gives like the worst color.
Okay, guys, if I can have you listen a little bit while we're still working. What did we find for carbon? How big is carbon? What is its atomic mass?
12.
Okay, well, what about oxygen
16.
and nitrogen?
14.
So they're all about approximately the same size, right?
Yeah.
Well, what about hydrogen? What size is hydrogen?
It's a small little dude.
It's super small. Okay, well, what about relative size? Who had glucose? Who made glucose? All right, Sam, what did you find relative between your glucose and their guanine?
Ours is, oh, what you guys
Are
get
they
for
about
more
the same
mass?
size?
What's your favorite more mass?
151.
Ours is bigger.
Not enough time.